Hi everyone, thank you for joining us for another episode of UNESCO Talks. I'm your host, Gabby Menezes. Today we're speaking to Anne L'Huillier, who is one of the 5 women to have won the Nobel Prize for Physics. Anne won the prize for her work around short pulses of light that can be used to measure the movement of electrons. Anne, welcome. Thank you so much for joining us.
Thank you.
So my first question, you are a professor in atomic physics. Could you explain what exactly that is?
Atomic physics is the science of atoms and more specifically really the electrons, because that are in atoms, because the electrons are interacting with the outside world. So it's really the interaction of the atom, especially the electron, with the outside world, for example with light. And one thing I'm studying quite a lot is the interaction between atoms via the electrons and light.
And maybe you could talk a little bit about your research that won you the Nobel Prize. My understanding it was looking at how atoms and electrons move and how to measure it.
The research that I've been doing during almost 40 years, it's about generating a new light when exposing atoms to strong laser light. And in 1987 we discovered that when atoms are exposed to intense laser light, we get high order harmonics of this laser light. So harmonics are light with frequencies equal to multiple of the laser frequency. And a few years later it became clear that if we combine all of these harmonics by interferences, we can get very, very short light pulses in the attosecond range. So attosecond is very, very short. It's 10 to minus 18 seconds. So through this phenomenon of high order harmonics, we can get pulses of with duration of the order of 100 attosecond.
And this is how we can measure how atoms move, is that right?
This is how we can measure how electrons move. We know how atoms move with the different techniques. But now we can measure really electrons in atoms and molecules, because it's the time scale of this very rapid motion of electrons, and we can use our light pulses, it's like light flashes, a little bit like flashes in a camera, to make very, very rapid movies.
And this is very theoretical, but is there practical applications for this?
Yes, there is practical applications, maybe not yet, but there are certainly applications inside. We still need to do research, but the challenge of the science is to understand better some chemical reactions which are initiated by a motion of an electron. It could be processes like photosynthesis or what happens in a solar cell. So to understand better the basic process and the beginning of this process. And if we understand better, because we can look at it, maybe we can control it and we can have application of this technique.
So you're one of the only 5 women to have won the Nobel Prize in Physics. Can I ask, how did that feel?
Well, I felt very proud and also I felt a kind of a responsibility. There are only 3 women in physics alive at this moment, so I'm one of the 3. So I felt very much the responsibility to use this honor to try to inspire, to tell the young women, the young girls, that science is great and they should try to go into science if they like it.
How do you think we can get more young women into the field of science? And maybe you could share some of your experiences working in a field that's dominated by men.
I think it's important to have role models, and in that way I'm hoping I contribute myself to the fact that maybe more women will try to do a career in science. I think it's important to encourage the young girls at an early age that they feel this is for them as well as for boys. And I think in the future it is important that the research group are diverse. There are women, men, there are people of different backgrounds. This is how a research team work best. And in addition, I think I'm very happy I chose to do science. It's a great career, so I hope there will be more women can have this type of happiness with their work.
Is there any woman scientists that you have found particularly inspiring?
I think I was inspired by Marie Curie, the fact that she existed and that she got the Nobel Prize in Physics very early, in 1903 I think, and that she came from another country, from Poland. She had difficulties, she had a family. She made a great discovery, which is radioactivity, which is really has an impact with nuclear energy, for example. I was inspired by the life and the achievements of Marie Curie.
Maybe talking about your own experience in terms of research, could you give our young audience members advice about failure and how it affected you?
I think life in general, and maybe science in particular, there are always ups and downs, and there are always difficulties. To be a good scientist, you need to be obstinate, resilient, not to give up. I think that's a quality to have in life in general, but especially in a scientific career. I would encourage the young people to not to be afraid. They will have difficulties, but you have to believe in yourself, and it will get better.
In your career, did you ever have a moment where you felt something in your research was not working? How did you get over that?
I had many such moments at the beginning where I was told to do something else, but I wanted to continue. Then at some point also when I moved from France to Sweden, I had to find a job. It was not so easy. And then at some moment nothing was working, and you have to go on. And maybe some colleagues find, for example, I remember very well when we did not know how to measure attosecond pulse. We were trying something, but it did not work. And now the two colleagues that shared the Nobel Prize with me managed to measure attosecond pulse. And this was a great moment because now we could continue. We knew how to do the following with our research.
And what was the breakthrough with the measurement of attosecond parts?
It was a breakthrough because, again, it was not clear at all how to measure these parts because you don't have any detector. This is so short. So you need to measure the pulses actually using the laser field, which is producing the pulse. So it was a very clever idea that my two colleagues pursued independently, but similar type of experiments.
As you know, UNESCO has the mandate for education and this belief that education as well as science and technology can spread peace. How do you feel about teaching and its importance to research?
To me, teaching is really essential, and I love teaching. I think I have been inspired by teachers. So in the first place, teachers are very important to inspire the new generation. And when you do research in science, I think it's as important to teach science. It provides a balance to the work that you do, and it gives you contacts with the young students. So to me, it's really very important.
And thank you. It was super interesting to chat to you.
Thank you.
And thank you for joining us for another episode of UNESCO Talks. As always, please leave your comments and questions in the chat and we will get back to you.